Alright, so this is a review of I should say this is a video for Exam 3, sections 3.2 through 3.6, and we've already discussed some things about problems 1 through 10, or I'm sorry, 1 through 9. So we'll do the rest of the problems, or at least some of those, and just talk about the different problems from 10 through the rest of the problems on the review. So on number 10, you aren't going to be able to factor this by grouping, so we're going to need to use synthetic division. But before we do that, I want to remind you about the rational zeros theorem. So if there's any rational zeros, those are numbers that can be written as a fraction. They'll be of the form p over q, where p is -6 and q is 1. And so our factors of -6 would be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And then the factors of 1, of course, are just plus or minus 1. So we're going to get plus or minus each of those numerator numbers over 1. So that's just 1, 2, 3, 6, and their opposites. And so at this point, we'd go to the calculator, and we should get one of those values. Again, I'm allowing you to get the first 0 off your calculator. If you didn't do that, otherwise you would have to basically do synthetic division with each of these numbers until you found one where you got a remainder of 0. So again, we're going to get our first one off the calculator, and 1 is a 0. So that means x minus 1 is a factor. So if we do synthetic division here, we're dividing by x minus 1. We'd be using 1 in the box. And then let's go ahead and put our coefficients down. We'll drop the 1. 1 times 1 is 1. Add 4 and 1, you get 5. Multiply, you get 5. Add, you get 6. Multiply, you get 6. And so we did get 0, which is what we expected, since we know that 1 is a 0. But the more important thing here is we can now factor f of x as x minus 1, since we already said 1 is a 0 and x minus 1 is a factor. But our answer, the 1, 5, and 6, let's see, we're going to drop our degree from x cubed to x squared. So it'll be x squared plus 5x plus 6. And then we can factor this trinomial using the AC method. And I'm just going to go ahead and do it. You get x plus 2 times x plus 3. We'll set those equal to 0. And so our zeros are 1, -2, and -3. So I would point out that you could have seen all of those on your calculator, but you need to make sure you're showing the work to justify your answer. You can only take 1 0 off the calculator. Alright, let's look at part B. In this problem, they're telling us that -1 is a 0. So, I'm sorry, actually we're going to skip this one, and we'll do C, and then D is very similar. So here it's saying 2 is a 0, so that means if you divide by x minus 2, you should get 0. So in that case, 2 would go in the box, and there's our coefficients. And let's just go ahead and do the math here. So you'd get f of x equals x minus 2 times x cubed plus x squared plus 9x plus 9. So notice the answer we got is 4 terms, and this does factor by grouping, and D will as well. Let's go ahead and factor that by grouping. We can factor out an x squared. I just went ahead and did the work there. You can just double check it. I'm just factoring by grouping, and so we've got this factored, and then we want to set each of our factors equal to 0 to find our zeros. So we're going to get 2 and -1, and then when we set x squared plus 9 equal to 0, we'll subtract 9 on each side take the square root of both sides, and you're going to get 3i and negative 3i. And notice this is a fourth degree polynomial. We did get 4 answers, which is what we expect. And letter D is going to work very similar. I do believe that on that, no, actually it's very similar. Let's go ahead and move on. On number 11, we're actually just listing all the possible rational zeros. So we're just, I call it finding our P's and Q's. So I'm going to do part B. And so our rational zero test tells us that any rational zeros will have the form P over Q, where our P is factors the numerator is factors of P, which in this case is 10. So, and then our Q would be the factors of 2. So the factors of 10 would be 1, 2, 5, and 10. And the factors of 2 would be 1 and 2. And so let's go ahead and put all of those over 1. That's going to give us 1, 2, 5, and 10, and their opposites. And then we'll put each of those over 2. 1 over 2, we get a half. 2 over 2, we get 1. We already have that. 5 over 2, we don't have that one. And 10 over 2 is 5, we already have that one. And so these are our possible zeros. Notice we don't actually have to find them here. Let's move on to number 12. So in each of these problems, we have to find the horizontal and vertical asymptotes. Let's go ahead and find the vertical asymptotes first. Those are the ones where we learn that wherever there's a restricted value, we're going to have a vertical asymptote. So on part A here, we're going to have to factor the denominator. You can verify that when you factor that using the AC method, you get x minus 7 times x plus 5, which means your restricted values are 7 and negative 5. And so that's where you have vertical asymptotes. On part B, when you set the denominator equal to 0 to see what values of x cause your denominator to be 0, when you solve this, you subtract 9 on both sides. We're going to end up taking the square root of negative 9, so we're going to get 2 imaginary numbers, which tells us there are no vertical asymptotes. On letter C, 5x minus 2, when you set that equal to 0, let's see, we'll add 2 to both sides and then divide by 5. So 2/5 is our restricted value, and again that's where we're going to have our vertical asymptote. On letter D, it's pretty easy to see that 5 is your restricted value, and so that's where we'll have a vertical asymptote. Letter E, we can factor the denominator, and again we want to see what x values cause that to equal 0. Well, either x equals 0 or x equals negative 2. And so those are restricted values, which means that's where we have our vertical asymptotes. And finally on letter F, if you factor that one, you get x minus 6 times x plus 1. So our restricted values are 6 and negative 1, and so that's where we're going to have our vertical asymptotes. And now let's talk about horizontal asymptotes. There were 3 cases. So if you look at letter A, here you have x squared as your leading terms. So these both have the same degree, the numerator and denominator. And so we say this one's balanced. In that case, we just take the coefficients of the leading terms. So 1 over 1. So y equals 1 over 1, which is just 1. That's going to be your horizontal asymptote. On letter B, notice the degree of the numerator is 1 and the degree of the denominator is 2. So this one's what we call bottom heavy, which means the horizontal asymptotes at y equals 0. Anytime you're bottom heavy, that's your asymptote's going to be y equals 0. Letter C is also, like letter A, balanced. And so the coefficients here are negative 5 and, or I'm sorry, negative 3 over 5. So y is going to be negative 3 over 5. On letter D, this time the degree in the numerator is bigger. We're what we call top heavy, which means we're not going to have a horizontal asymptote. On letter E, we're balanced again. Notice we have a degree of 2 in the numerator and denominator. Now be careful here. The coefficients here are negative 1 and 1. Negative 1 over 1 is negative 1, so we're going to get y equals negative 1 as a horizontal asymptote. And finally on F, let's see, the degree of the numerator is smaller. This is the case where we're bottom heavy, which means y equals 0 is going to be our horizontal asymptote. So make sure you know how to find your vertical and horizontal asymptotes. It's going to be very important when you're working with rational functions that you can do that. On number 13, we're actually going to go through the whole process of graphing. And the one that you'll do on the test will be very similar, or I should say comparable to A. The others are a little bit long, certainly for a test. So let's go ahead and do this one. So first of all, we want to find our asymptotes. So notice x can't be negative 2 here, so that's our restricted value, and that's where we're going to have our vertical asymptote. Notice this one is balanced. The degree of the numerator and denominator is 1. So we're going to use the coefficients 2 and 1. 2 over 1 is just 2, so y equals 2. Next we want to find some points. So the x and y intercepts are usually two easy points to find. So the y-intercept's found by letting x be 0. So let's go ahead and plug 0 in. In the numerator we're going to get negative 1, and in the denominator 2, so we get negative a half. So 0, negative a half is our y-intercept. For the x-intercept we want to let y equal 0. So we're going to get 0 equals 2x minus 1 over x plus 2. Let's go ahead and multiply each side by x plus 2 to clear the fractions. You're going to end up with 0 equals 2x minus 1. So we'll add 1 to both sides and divide by 2, and we get a half. So when we chose y to be 0, we got a half for x, so 1/2 0 is our x-intercept. Let's go ahead and graph this. So first of all, let me put my asymptotes in. We've got one at x equals negative 2 and y equals 2. And let's put in the 2 points that we got, our 2 intercepts. So notice with these 2 points, we know that the end behavior, I should say the y-intercepts basically tell us what the graph's going to look like on the ends. So this graph is, if you draw, you can see that the way that these 2 points are, the graph is going to go up, or it's going to approach the horizontal asymptote to the right. And as you go to the left, it's going to continue to go down, but it can't cross that asymptote. So it's going to look something like that. You really only need 2 points in each region on a graph like this. So let's go ahead and find a couple other points. We need some points on the other side of the vertical asymptote. So maybe when x is negative 3. So let's go ahead and plug that in. You get 2 times negative 3 minus 1 over negative 3 plus 2. We'll get negative 7 over negative 1, which is 7. So when x is negative 3, y is 7. Let's go ahead and put that point on the graph. And let's plug in negative 4. So we can do the same thing. Let's see, negative 8 minus 1 over negative 4 plus 2, we're going to get negative 9 over negative 2, which is about 4.5. And so we get 4.5 when we choose x to be negative 4. Let's go ahead and put that point on the graph. And again, you can see as we go to the left, we're going to get closer and closer to that asymptote. On the other end, we just get closer and closer to the vertical asymptote, but we can't actually cross it. And that's going to be it for this one. Alright, so this is actually number 14. I'm going to go ahead and do this one, and I'll just give you a couple tips on the other two. So first of all, there are some steps we need to follow when we do solve these quadratic inequalities. First thing is we need to get 0 on one side. So let's add 4 to each side. And so now we want to look at the equal case to find our critical values. We want to know when the polynomial, or the quadratic function in this case, or the quadratic polynomial is equal to 0. So let's set it equal to 0. So we're looking at the equal case to find out when this polynomial equals 0. So we're going to use the AC method. We need two numbers that multiply to 8 and add to negative 9. And you can try it, but it's going to end up being negative 1 and negative 8. So let's split our b term. There's no shortcuts on this one because we have a 2a squared. So we'll factor this by grouping. We can factor out an a there. So we're expecting a 2a minus 1 when we factor this other, these other two terms. So we need a minus 4 to make that work. So we're going to get 2a minus 1 times a minus 4. Again, that's equal to 0, so we're going to get 4. When we set 2a minus 1 equal to 0, we get 2a equals 1, or a equals 1/2. So these are our critical values, or our borderline points. Boundary points, I believe is what they called it in my math lab. So there's a number line with our boundary points on there. Notice because we have the less than or equal here, we're including our the values of x that make us equal 0. So that would be the 1/2 and the 4. So those are 2 points that are solutions to this inequality. And so now we're going to do some test values to see if, or what intervals are solutions to the inequality. So we're going to want to choose something to the left of a half, like something smaller than a half, like 0. 1 would be a nice number in between a half and 4. And then 5 is greater than 4. So let's go ahead and let's write this polynomial in factored form. We want to know when that's less than or equal to 0. So we're just working with what we have right here. But we're working with it in factored form. Alright, so let's go ahead and plug in 0 and see if that works. Let's see, 2 times 0 minus 1, that's negative 1 times negative 4. And that's going to be 4, which is certainly not less than or equal to 0. So that's false, and so we will not shade there. Let's plug in 1. So we're going to get 1 times negative 3, which is negative 3. And that is less than or equal to 0, so that's true. And so we're going to shade that region, that interval. So the idea is if 1 worked, every other value will work. And then let's go to test 5. So we're going to get 2 times 5 minus 1, which is 10 minus 1, or 9. 5 minus 4 is 1, so 9 times 1 is less than or equal to 0. That would be 9. And that's not less than or equal to 0, so that's false, and we will not shade that interval. So our solution is going to include our points, our borderline or boundary values, and then everything in between. So that's going to be 1/2 to 4, and let's see, let's move on to the next problem here. So basically we've got 15 and 16 here. I'm not going to do these problems, but I'll at least get you started. If you look at the first one, I don't really like having that x squared, or the negative x squared there. I like our leading term to be positive. The easiest way to take care of that problem is let's just multiply each side by -1. The problem is with inequalities, if we multiply or divide by a negative, we have to reverse the symbol. So this becomes x squared is greater than -5x. All I did was multiply each side by -1. Again, I got to reverse the symbol. And we need 0 on one side, so let's go ahead and add 5x to both sides. And so we get x squared plus 5x is greater than 0. At this point, you could factor out an x, and you'll have your boundary values, and then you can go from there. On number 16, it does factor by grouping, and so you'll want to do that to get your boundary values. And again, you can find the details on the answer sheet, but that's going to do it for this video.